Hello, I'm Kevin, VK6 Lima Whiskey, and just like to share with you a receive antenna that I've recently built. It's mainly for the HF bands. I'm trying to optimize my receive performance on HF, mainly for SO2R operations in contests. So I've got separate receive antennas for the low bands. I've got delta loops on ground, and they really work quite well on 160, 80 and 40 meters. But I was keen to have something that worked a bit better and had a really good signal to noise ratio on the HF bands. So previously I've been using off-center fed dipoles or extended double ZEP antennas for the HF bands as receive antennas, located about 100 meters away from the main transmit antenna. So that gives me some physical distance. It helps a little bit with the filtering. If you're running SO2R and you're on 40 meters, for instance, you've got the second harmonic on 20 meters, it's handy to have some distance between the transmit antenna and the receive antenna. But it also helps if the receive antenna is a low noise antenna, and it helps if the antenna is reasonably efficient. So whilst I was not unhappy with the OCF antennas or the EDZ antennas, I felt I could do something a little bit better. So I modelled and built this loop. It's essentially a loop that's around about a full wavelength on 40 meters. So it's 18 meters in length, and it's around about 3.35 meters height. And the bottom wire is only around about 2.1 meters off the ground. So it's fairly inconspicuous. I've just put this up in the trees, about 100 meters away, as I say, from the transmit antennas. And it's got a feed point here at this end, in the center, which just fed straight in with 75 ohm coax. The other end, there's an optional load. I'll come to this a little bit later on. This has got something to do with trying to use this on the low bands. So with the antenna as it is, this is an example here on 28 megs, 10 meters. I get quite a decent pattern. What I'm really interested in with this antenna is trying to get as much vertical polarization as I can, because the transmit antennas are horizontally polarized, and if I can build receive antennas that are primarily vertically polarized, that helps me quite a lot, because it helps to reduce the interband interference on SO2R. So the red line here is the vertical polarization. The green line, which I still have some of, is obviously horizontal, and the blue line is the total pattern. And you can see here that the gain's not huge. It's 2.81 dBi, but at a fairly low angle, and that's better than maybe considering just putting up a vertical dipole. The match is pretty good. This is straight into 75 ohm coax. It's an acceptable match on 40 meters. If it's just only a receive antenna, that's okay. The match on 20 meters is very good. Match on 15 is good, and the match on 10 meters is certainly good enough for a receive antenna. I normally feed these antennas with RG11 75 ohm coax. You can feed them with RG6 if the antenna's not too far away, but with a 100 meter run, I think it's better for me to run with RG11, and that seems to work quite well. So if we have a look at 15 meters on here now, just run the plot on this, and we'll see on 15 that it's good enough. We've got some low angle here. We've got a good vertical component, and again the gain's not huge, but it is at a low angle. If we have a look at the azimuth, it's pretty omnidirectional, which is another feature that I'm keen on. I don't really want an antenna that's too favours any one direction really as a receive antenna that you're just switching to automatically in SO2R mode. So this is pretty good on 15. If we have a look on 20 meters, run the plot. And we can see on 20 meters here that again we've got a fairly consistent vertical radiation pattern. It's probably a little bit more vertical than there is horizontal. Hard to eliminate the horizontal altogether. That's a project for another antenna I'm working on, but this is good for a low antenna here. And it's if we have a look at the azimuth, yeah, it's got a nice sort of cloverleaf omnidirectional pattern, so that's really good. And as I say, the match is okay. Also have a look on 40 meters, because it's the match is not so good on 40, but for a receive antenna it doesn't really make too much difference. And on 40 we can see here that it's actually, there's very little horizontal polarization, and the azimuth pattern will show us that it's fairly broadside to the plane of the antenna, so a little bit of rejection off the ends here on 40 meters, which is no bad thing. You can just see the red line in here, which represents the vertical radiation, and you can see the green here obviously represents the horizontal. So certainly very usable on 40. I've been testing this antenna out on the HF bands, and it's really quite good. And the really nice thing about it is it's got a very low noise level. I was quite surprised that how low the noise level on this was. So with the FTDX 101 set up, with both receivers synced up, it's quite easy to do some tests and switch between or have a look at the comparison between the main HF beam and the received performance of this antenna. So there is a way to also make this antenna work effectively on the low bands, and I will come to that in the next video. 73s for now from me, Kevin, VK6 Lima Whiskey.